Hi everyone, we're on the back side of Factors and Multiples, Handout 1. So here we're going to start talking about multiples. So multiples are really just the numbers that you get when you multiply other numbers together. When you look at a multiplication chart or something like this is like the first 12 multiples of 7. 7 times 1 is 7, 7 times 2 is 14, right? 7 times 3 is 21, and it continues on. Any number times 0 is going to be 0. So 0 is its own multiple of every number, but really you're just multiplying that first factor by another factor, and then you end up getting the product. Well, that product is also known as a multiple, right? And there's an infinite number of multiples, okay? So in our fill in the blank here for the multiples section, a multiple of a number is the product of multiplying that number by another number, okay? Notice multiples, multiply, right? The word is right in there, and you can do this infinitely. Okay, so for example, the first 5 multiples of 7 are 7 times 1, which is 7, 7 times 2, which is 14, 7 times 3, which is 21, 7 times 4, which is 28, and then 7 times 5, which is 35. The least common multiple is the first or least common multiple of a set of numbers that they have in common. So again, we just talked sevens, right? So the same thing for right here within this list, right? This is 7 times 1, 7. When you're listing the multiples, you would just list the 7, 14, 21, 28. It's a lot like skip counting when you first learn that, right? Same for 8s. We're counting up by 8 each time. This is 8, 16, 24, 32, 40, 48. Okay, and you can literally do this forever infinitely, all right? So those are multiples. Below here, we're going to list out the first 10 multiples of each number and then determine the least common multiple that the two numbers have in common or share, okay? I would use the multiplication chart to help you. You should each have a multiplication chart in your math binder. You also have one in your agenda that was provided by the school, or you can always look one up or print one on the internet too. So for 4, we're counting by 4, so we have 4, 8, 12, 16, 20, 24, 28, 32, 36, and then 40, because 4 times 10 is 40, so that's the first 10 multiples of 4. Then we're going to do the same thing for 9. So you have 9, 18, 27, 36, 45, 54, 63, 72, and so on. I stopped a little shy there of listing all 10, sorry. So if you were to continue this, so after 72 would be 81, and then 90. Sorry for skipping that. Let me just fill that in real quick. So 9 times 9 is 81, and then of course 9 times 10 is 90, and then those little dots continue on forever. So the least common multiple of 3 and 9 would be, of 4 and 9 would be 36. Okay, so 36 is the least common multiple that they share. It's the first number that you run into that they each have in common. And coincidentally, 9 times 4 is 36. So sometimes that will happen. We might notice a pattern when we're working with prime numbers. For 4 and 9, it just happens to be 36. So 3 and 7 are both prime. Let's see if that happens here as well. So first listing the first 10 multiples of 3. So again, 3, 6, 9, 12, 15, 18, 21, 24. I stopped short again. I don't think I read the directions with the list the first 10. So after 24, well, 9 times 3 is 27, and then 10 times 3 would be 30, and so on, okay? And then for 7, we have 7, 14, 21, 28, 35, 42, 49, so 7 times 7 is 49, right? So 7 times 8 is 56, 7 times 9 is 63, and then 7 times 10 is 70. Okay, so that fulfills the directions of writing out the first 10 multiples of each. And then the least common multiple, or the first number that they have in common is 21, okay? So you can see here they each share 21, and that's the first one that you run into. It also happens to be the product of 3 times 7. Now, 3 and 7 are both prime numbers. That means their only factors are 1 and themselves. So when you have, when you're trying to find the least common multiple of two prime numbers, you can just multiply them together to get that product, okay, that least common multiple of 21. So below here we have some word problems, and these can start to get a little tricky. So we're going to start to teach you some clues to help you figure out whether or not you're finding the least common multiple, which is the LCM, of course, or the greatest common factor, because oftentimes the word problem does not tell you that. Instead, it just gives you some clues. Okay, so we'll give you like an entire list of clues, but for now, we're just going to get started on practicing this. So here we are applying our understanding of factors and multiples to answer the questions below. So for number 5, Ella and Ethan planned a barbecue. BBQ is barbecue for their soccer team. They purchased 60 hot dogs, so 60 hot dogs, and 48 individual bags of chips. Okay, so the first part of this that we need to answer says if each person will receive the same amount. So same amount is clue for GCF. Okay, that's one of your clues. Right, same amount of food, and there will be no leftovers. That's like no remainders. Okay, that's another clue. So no leftovers. Each person's getting the same amount. What is the greatest number of people they can feed? There's another clue. When you see the word greatest, we're often talking GCF, the greatest common factor, okay? So the GCF is what we're going to be looking for. And of course, we're looking for the GCF of 60 because they got 60 hot dogs, and 48 because they got 48 individual bags of chips. So again, we're taking notes right now. At first, this might seem a little bit overwhelming. Just take the notes and see how it goes. And as you continue to practice this, I promise you, you are going to get better at it, okay? So for 60, we're first going to make a factor tree. Again, you're going to have like many more notes and practice on factor trees. So I start with just writing in, like boxing in the number 60. And then I'm thinking of numbers that multiply together to equal 60. So I know 6 times 10 is 60. And then I want to continue to break this down. I'm just going to zoom in for a second. 2 times 3 is 6. I circled the 2 and the 3 because 2 and 3 are prime. And then, of course, I need to factor out the 10. And 2 times 5 is 10, okay? So the prime factorization are all the numbers that multiply together, all the prime numbers, to equal 60. That's going to be 2 times 3 times 2 times 5, okay? Right? 2 times 3 is 6, 2 times 5 is 10, 6 times 10 is 60. So that should make sense. And then we're going to do the same thing for the chips. 4 times 12 would give me 48. And then I need to factor out the 4 because 4 is not prime. So I know 2 times 2 is 4. I'm going to circle those 2's. And then I want to do 3 times 4. I could do 2 times 6. It doesn't matter. 3 is prime, so I'm going to circle that. And then I need to factor out the 4, and I get 2 times 2. So the prime factorization of 48 would be 2 times 2 times 2 times 2 times 3. Okay, so there's 4 2's and 1 3. Okay, now I need to look at what they share or have in common, right? So what these factor trees have in common. So they share or have in common a 2 times 2 times 3. Okay, if I kind of break that down and circle it over here in blue, it might be a little easier to see. They share a 2, a 3, and another 2. You see that? A 2 times 2 times 3. Okay, so 2 times 2 is 4, and 4 times 3 is 12. So 12 is the greatest common factor. That means that 12 people, right, this is a soccer party, 12 soccer players can be fed without leftovers. All right, so hopefully they don't have more than 12 people on their team. Now, here's where it gets a little strange, right, in this thinking, because this is probably not really realistic. So what will each person receive? So if they're only feeding 12 people and they're feeding them the 60 hot dogs that they got, remember they bought 60 hot dogs? Well, 12 times 5 is 60, or you could say 60 divided by 12 is 5. So that means each person's going to eat 5 hot dogs. I hope there are no vegetarians, and I hope that they really like hot dogs because that's like a hot dog eating contest, right? That's way too many hot dogs for one meal. So just to satisfy the question here with this problem, they're each going to eat 5 hot dogs or get 5 hot dogs, right? And then when it comes to the chips, well, they bought 48 of like the small little single serving bags of chips, right? And 48 divided by 12 is 4, or you could say 4 times 12 is 48. So each person's getting 4 bags of chips. So again, this is a GCF, a greatest common factor problem, and we know that from the clues up here, right? We know that from those clues we talked about, same amount of food, no leftovers, greatest number of people they can feed. So the GCF was 12 people, and we take it a step further. What are they going to receive? They're each going to get 5 hot dogs because they purchased 60, and 60 divided by 12 is 5. And then they're each going to get 4 bags of chips because they purchased 48 little bags of chips, and 48 divided by 12 is 4. All right, so the next question is, you guessed it, a least common multiple question. So let's look at why there are some clues here for the LCM, or least common multiple. All right, so the Vasquez family visits their grandmother every 3 weeks. So believe it or not, just this one little single word, every, is a clue, okay? Every 3 weeks. And they spend a day volunteering every 8 weeks. Another clue, every. Okay, so every 3 weeks and every 8 weeks. Every 16th week, the Vasquez family takes a day to go hiking, okay? We are finding the least common multiple, or the LCM. So the first question, letter A, says, after how many weeks will the Vasquez family both visit their grandmother and volunteer? So the both, again, this is when they're both going to come up in their multiples and have that in common, okay? So there's another clue to say we're finding the least common multiple. So I'm going to start listing the multiples of 3. Again, they're infinite, but I'm just going to get started. Just like skip counting. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so on. 12, 15, 18, 21, 24, okay? Now for 8, we're going to do 8, 16, 24. Oh, look, they have 24 in common. So 24 is the least common multiple. The LCM is 24. So they're going to both visit their grandmother and volunteer every 24 weeks, okay? Now the next question says, after how many weeks will all 3 events occur? Okay, that means within the same week, they're going to visit their grandmother, because they do that every 3 weeks. They're going to volunteer, which they do every 8 weeks. And they're going to go hiking, which they do every 16th week. So that's going to be a busy week, and that will fall on the 48th week. How do we know that? Well, we're literally just, again, continuing listing the multiples of 3 all the way till we get to 48. I actually start with a bigger number first. Same thing with 8, goes all the way up to 48. Of course, we know it keeps going, but I'm going to stop there because so far they have that 48 in common. And then 16, 32, and then, of course, 48. So every 48th week is the answer to that chunk of the problem. Now, for the summary of today's lesson, if you don't want to write all this out right now, that's okay, because the vocabulary is on the back of the homework sheet, which I'm going to go over with you when I review the homework with you. Actually, I'm going to review it right now. But so factors multiply together to equal a product. The GCF is the greatest factor a set of numbers has in common. And then multiples are infinite. The LCM is the least common multiple a set of numbers has in common, okay? So on the back of the homework sheet, just to go over with you real quick, you have some little vocab cards, and I really like these. They have little pictures, makes it hopefully a little easier for you to remember. So Factor Ninja chops up numbers into factors. So for example, the factors of 16 are 1, 2, 4, 8, and 16. Later, we're going to talk about a factor rainbow too, which this doesn't talk about, but I'll just show you real quick. Like 1 times 16 is 16. And then you do the next arc of the rainbow. 2 times 8 is 16. And then 4 times 4 is 16. It's only showed once because 4 is the same number, right? So it's a factor rainbow if you want to even add that on to like your little Factor Ninja card. Factor rainbow, okay? So these notes are already here for you, okay? And then you have prime number, right? So if you forget what a prime number is, primarily has factors of 1 in itself. Okay, so you're going to look at like all the prime numbers later between 1, well, 1's not prime, but between 2 and 100, which we'll look at later. So 2, 3, 5 are prime because factors of 2 are only 1 and 2. 1 times 2 is 2, right? Nothing else multiplies together to equal 2. Factors of 3 are 1 and 3, right? 1 times 3 is 3, that's it for factors. For 5, 1 times 5 is 5. Okay, so those are the first 3 prime factors. There are many more. And then composite factor is the opposite of a prime number. They're composed of many factors, like composite numbers. 4, 6, 8. Factors of 4 are 1, 2, 4. Factors of 6 are 1, 2, 3, 6. Factors of 8, 1, 2, 4, 8. Okay, so composite number has many factors. And then multiple monster, just a good way to remember, it makes a number get bigger or greater. Multiples of 9, of course, are infinite, that little infinity symbol, because they just go on forever. But here's the first 1, 2, 3, 4, 5, 6 multiples of 9. Okay, so just nice vocab on the back here for you to help you review. Thank you guys. Great note taking. Try the homework, please, and then watch the homework video to check your work. See ya.